Here is an explanation for the answer to final exam. Question number 14, found on page 664 of Teach Yourself Electricity and Electronics, edition number 5. We're talking about a wire that carries a constant direct current. Let's imagine that that wire comes right out of the screen at us and goes back straight behind the screen, or the whiteboard, the dry erase board, which is evolving, by the way, into a wet erase board pretty fast. These things don't last that long, some of them, the cheap ones. Anyway, the wire is perpendicular to the surface, so it comes right at us. Now, the question asks us what happens to the flux density around a wire like that that carries a constant direct current. Well, if we were to be able to see the magnetic lines of flux, they would look like circles in this cross section, and they would be closely spaced near the wire and spaced farther and farther apart as we got farther from the wire, if each line or curve of flux represents a certain amount of overall magnetism. So, the flux density, which is the number of flux lines per unit distance or area, gets smaller and smaller and smaller as we get farther away from the wire. That is choice A, as in alpha. The flux density around a wire that carries a constant current decreases as we get farther and farther away from the wire.